and a new use for the humble nylon fishing line.
In the early 20th century, the war effort was in full swing. For everyone back home, this meant strict rationing of basic supplies. Silk was vital for making parachutes, and when silk stockings disappeared from shop shelves, women began to despair. Scientists came to the rescue by creating nylon, the first synthetic fibre. Lightweight, stretchable and very strong, this new polymer chain fibre was widely used in fishing line, ropes, parachutes, plastics, fabrics and of course, the nylon stocking. Now the humble nylon fishing line has a powerful new use.
We can produce artificial muscles from fishing line that can contract by about 50% of their length. They can generate forces that are over 100 times larger than our own muscle and produce a mechanical power output of over 5 kilowatts per kilogram, similar to a jet engine.
An international research team has developed these artificial muscles. In Australia, the team is led by Professor Geoffrey Spinks.
The advantage of using something as simple as fishing line or sewing thread is that they're really cheap and they're readily available, where we actually went from something exotic like carbon nanotubes and actually improved the performance of these artificial muscles using everyday materials. The tools we need to make the fishing line muscles are fishing line, a hairdryer and an electric drill.
Simply attach a piece of fishing line to an electric drill.
And the other end of the fishing line, we attach a weight to it so that the weight provides a bit of tension, and then we turn the drill on and it starts rotating. We have to stop the other end from rotating as well. So one end is twisting, and eventually we go into a phase called over-twisting where the fishing line actually starts to form a coil.
Finally, a blast of heat sets the shape and it's left to cool.
And then to make it work as an artificial muscle, we just apply a little bit of tension again and then some more heat. So we can have really thin or really thick polymer fibres, but the amount of force that we generate increases as we go to thicker and thicker fibres.
But could these artificial muscles actually be implanted into humans?
Now that's a major challenge, of course, to be safe to be able to do that. But if it is successful, then we could perhaps develop technologies that can replace injured or diseased muscle. Then that would be a really exciting possibility.
But in the short term, these artificial muscles could revolutionise prosthetics and even put a smile on the face of humanoid robots.
The muscle can be as thin as the diameter of our hair that can generate the force and movement like a motor can. That means we can fit them into tiny spaces. We can make robot hands that have high dexterity and therefore perform more complicated tasks.
In development is a new lymphedema compression sleeve, which will use these muscle fibres to gently massage the arm.
A garment that will do the job of a masseur but do it all the time and hopefully even prevent the build-up of lymphatic fluid and the discomfort that it causes.
And woven into everyday clothing fabric, this could create the new wonder garment.
If we get too hot, the muscles can expand, the weave can open up, and that can release some body heat and we can cool down. So this would be powered by only our own body heat.
In a similar way, a building could be cooled down.
A greenhouse or a building where if the temperature builds up inside, the muscle would contract and open a vent or open a window.
And unlike our muscle fibres, they never seem to tire.
The lifespan of our polymer core muscles is excellent. We've tested for 1 million cycles and there was no degradation performance at all.
And with this capacity, future applications of these artificial muscles are very exciting indeed.
You're starting to sweat.